Okay, for starting, I want you get to understand what a little bit is Hipreme Engine all about. I think the subtitle shows it. I'm trying to bring D to every platform. I wanting to test it however I can, and I want to prove its capabilities for it being at least a little more known, I guess, for gamings. Okay. So, yes, I think for understanding the project, you need to first understand me, who I am. I have been programming games for like 6 years right now, but I have started like introduced in game development more than 12 years ago. And yes, I'm a game programmer in my usual workday, but I'm also an engine programmer for hobby stuff. I also worked a lot on open source tools for Love 2D, and also I do a lot of music. The main languages I use there is D and TypeScript, and after that, those are all the languages I have done tons of projects or researched a little bit to understand how I can make things a little better. So the Hipreme Engine is like a real big project right now. It's 95% D code. You can see I have also used a lot of programming language with it because it just makes life easier. It's 2D, completely avoid C. I don't want any C code in my engine unless if it's only for calling D code. It's OOP based. It also supports hot reloading, and those are all the platforms I'm supporting right now. So I want you to get the idea of how did I start this project. I have like the usual way using SDL2 because it promises a lot of portability. I wanted also to use abstractions for making things easier. Do it the D way, like using classes, templates, how much I could use of D-only stuff, like also metaprogramming. And also the main reason this project started was because I wanted to understand the 3D APIs. I think they were really hard, so I think that's the most successful attempt of understanding them. And right after that, I present to you my main references for building this engine. The main references there that you put some focus is libgdx and love. Those others, they are pretty okay, but I think they do not let you be really free with your programming instincts. So I don't really like that about them. But I still need to look upon them because they do present a lot of of really cool concepts in a lot of areas such as build tools or other things, and how easy it is to get starting with them. So although this is the first thing I started talking about code, it really took some time until I get to this phase. I think my work on Android was done in 2019. This was really hard to get. I think it was really in the start of Android 4D. It was really untested thing. Like the only project I think you could find was the build script add-on done for Android. It was really complex, so I wasn't able to understand. I was looking like every kind of documentation I could find for Google and Android. You need to understand a little bit of architecture, so it was really amazing how hard this thing was, especially because there was some C APIs I were using back then. And after that, I have started porting my engine for Xbox Series. It was a real obvious choice because the developer license is really cheap, like $20. And like this thing is a complete mess. It completely changed how much my project was going. Like everything C done didn't work on Xbox because Microsoft created this C++/CX. It's a complete mess of a language. Yeah, I really despise it. It's a customized C++, which you have a custom operator for working with smart pointers. No one really bothered with it. No one really liked it. It created unportable projects. So later, Microsoft gave up on it and created C++/Win runtime. And that's what I'm using right now. The Universal Windows platform works a lot different from Win32 API. It's really unbearable how lack of documentation you have on this. And yes, you can see DirectX there. Yes, you can't use OpenGL on Xbox. So even with OpenGL not working, you can see SDL nothing worked. So I was beginning to dump every C dependency I had because nothing did work. I need to integrate every build system from them, like with the native build system from the platform. So I would need to build SDL with makefiles, build D with dub, then include those two build results with the Microsoft tool. So it was becoming just unbearable. And after that, I've learned a lot of lessons here. You can see shared libraries really rock. It's how I've been doing this connection from the language and platforms with D, because the C shared libraries are supported, so D is usually 2. So it's the easiest way. The thing I prefer most here is having things easy to work. Other thing that's pretty noticeable is using more than one language. And why have I done that? Doing everything with D looks pretty nice, but has a fatal problem, which, for example, integrating with Java, I would also be able to have Java libraries in my belt. So if I didn't use the Java code for starting my D code, I would not be able to integrate with important APIs from Android, like having those advertising APIs, those security APIs that Google demands you to have. And also, the thing is, try to completely avoid C dependencies. C doesn't really work on Windows. It makes your life just painful. C is not supposed to be used on Windows from my experience. They doesn't really like beginners too. I can be like that. And yes, use D libraries. D is a pretty portable language from my experience. It's really easy to understand what is happening. Having those fixed size types really helps a lot into getting the ABI correctly. And yes. So I had a new plan after looking to those 2 portings I've done. I was going to need to port everything first. Like you can see, those are 2 platforms I showed you, but I support right now 7 platforms. And after every platform I've done, I was needing to do some kind of refactor, and I just got enough from that. So I just would port everything first before doing any kind of high-level feature, so I could work with interfaces and better versions and code portability. And yes, with those refactors, I got a lot more of stability, and also it would prove that D is much more than a sandbox where you're just toying with things, because if your language is able to be everywhere, I think that's a pretty nice indicator that it's going to work nicely. And yes, I was just testing D there. And yes, this is a big stuff. WebAssembly was really hard to get through. And then I looked a lot in the internet if anyone had done anything about it. I found first this Art of Machinery blog, which is done by a Japanese D programmer. He showed how he used AM scripting with D. And yes, it's really complex. This guy used Docker too, so it's not really approachable. And you can see the year is 2018. By this time, LGC was already dropping support for AM scripting and embracing WebAssembly, so I guess this is more of a reason to not use it. And also, it introduced a thing I call the two-step compilation phase for always trying to bring the native tool with your D tool. So, for example, you can integrate easily Asyncify with D if you use the AM scripting compiler with a D object. And this is a game made by Sebastian that I have found. It was pretty resourceful thing he done, because it showed me a lot on how I could get OpenGL working with the WebGL code. It's pretty straightforward. You need to convert JavaScript objects to basically numbers. It also gave me a lot of more ideas after doing this project. And those are the main problems I found when I was doing the WebAssembly port. There was no D runtime. I even thought about doing using a better C code, but it's not my cup of tea. I think the code becomes pretty ugly with time. When using, you do a lot of indirections for getting stuff done. I prefer easier and direct things. You can see there's almost no references in WebAssembly. No one is using it at all from my experience. I guess WebAssembly stuff were created for using with 3D applications. And I think this is why you should not use D with WebAssembly if you're not doing games or 3D applications, because you need to access web pages with D. These would not be portable. And the projects I had to look up, like Godot Engine and Unity, they were just too big to me to understand anything about it. So it didn't help much. So after that, I found some hope in the internet. Adam had done his WebAssembly runtime, which was then used as a basis for lightweight D runtime that I guess I don't remember his name right now. Adam basically implemented a small runtime with almost no features. He handled for the hardest part in the WebAssembly, which was initializing the heap memory with the correct address. He implemented also the allocator for classes. So after that, I went into looking up his work into extending it. And thanks to Dennis, I was able to test my runtime. I was looking into the documentation he just made, and I was looking at what kind of code triggered D hooks. And with that, I don't expect you to read this at all. It's just a bunch of tests of every D hook feature I found, like the string switch, the assertion. There's also the automatic decoding that we use it a lot too. The delegates, classes, interfaces, dynamic caches, and everything like that. It was really boring to do that. And after that, we finally reached something with WebAssembly. But the first thing you need to understand about WebAssembly is that its bridge with JavaScript is just too slow. Like, I'm not even joking, it's 100 times slower than running normal code without any bridge. It's really, really slow. But that is not really a problem when you're working with OpenGL and WebGL in that case, because for good practices in game engines is batching your calls, so you try to access the less you can from the APIs, so that doesn't stood as much as problem when looking at that. But if you're trying to get your job done, please don't use the bridge whenever you can. Also, don't use a C standard library. I think this is the main reason my engine is almost not reusing any kind of feature from Phobos besides metaprogramming. C standard library is just complex. It completely depends on the web, from using async which makes your code even slower, bigger, and also maybe unreliable. So after that, I completely not using anymore the C standard library, so also implemented a minimal runtime for a minimal standard library from Phobos, like 60 lines, I guess. Also, it's pretty important in the web to understand the web philosophy. You can't run your code in synchronous mode. It's impossible unless you use this async thing. This async it's pretty bad, so I would not use it anyway. So when designing your code, you need to think about designing it to work concurrently. So, like, as I was saying to Walter minutes ago, there was those file things. I even done all this stuff, but it wasn't good enough. I needed to always change my return value to some kind of result. This result would behave like JavaScript promises, so that I could at least wait from them. I done a complete refactor on my asset loading style. Yes, after that, the most popular subject, the garbage collector. There's no collection. It's pretty simple to solve that. But you may be thinking, well, but if you're not collecting anything, how do you expect this to run? Well, as said yesterday, the best code you can do is getting to no allocation at all. So the best thing you can do with no collection runtime is sticking to good practice programming. So like using object tools and allocating upfront, so you won't run from memory. My engine doesn't allocate any kind of memory in its update function, so I'll never miss any kind of memory, especially for any kind of game you'll be doing. You have at least 4 gigabytes, so it's just too much. Just do your code correctly, then everything works. Then the WebAssembly communication with D was pretty complex stuff. You needed to externalize a function to call D functions. But because these D functions I'm saying are not usual ones, they are function pointers, callbacks, or delegates, however you want to call them. And then I would send from the code an address to JavaScript to save this address, and then I would use a function table for calling my callbacks. So this way, JavaScript would be able to call any kind of delegate, so I would have access to sending it arguments or just waiting for its result. I also done some work into validating the arguments, because it's pretty easy to just get the arguments wrong when you're using WebAssembly. So yes, you at least check how many arguments you did receive and the size. You can look into its type, but I think that's mostly enough. This is not something the user should be looking into. It's an internal engine thing. And after that, I'm showing here how I was able to implement the delegation call inside JavaScript. You can see I use promises to load files inside web. Then I send this success handle with it's the function pointer address, and also have to use some kind of util tools here to convert from JavaScript objects to the arguments and how I'm expecting. You can see there's also a lot of string conversions here because they doesn't work. Another thing that's pretty important is using those tuple-off. Web doesn't really behave correctly when you're using structs. It becomes pretty messy. So the easier way is just using this tuple-off expansion. So you have a lot of arguments. So you need to try to wrap your arguments inside structures, and just remember to put this dot tuple-off. And after that, I needed to do something about the WebAssembly file system, especially since because there's no knowledge from the web if your file even exists and how big it is. So I've done a simple tool to convert your assets directory to some metadata that you have when you're coding to WebAssembly. And with that, I also used the compile time import for having this information on the compilation time. It also helps a lot. This is also another thing I have done a tool for D. There's a lot of tools working on background for making things at least work. It's a technique I have found when I was talking with Paul. Basically, I need to save every module name so I can iterate on your entire source, looking for special tokens, or however thing it is. In this case, I'm trying to load and understand which files are required for your build. So whenever you use this UDA asset, you're able to get this information from your game scene before you're actually instantiating your scene. So this is a quite nice trick for dependency management when you're working on a game. It also supports a custom parser that you can just pass it as a second argument. This is how the game actually runs on web, since it just needs to preload everything concurrently before even running this game update. This is how the web is able to know how your assets are there. I use it a lot, this trick I've learned with Adam, which is the interface with a mixing template member. And then you create another mixing template for storing your implementation. And then when you need to use this on a child class, you can also just select if you want to override it or not. This becomes a lot cleaner. And this is a thing I'm thinking about right now. It's a thing I call as asset loading strategy. It can change through time, like if I want to get bounds from the window to understand when the assets are loading, or you can just load every asset before trying to run the first scene of your game. This is a pretty nice technique I found while working with assets, at least. And this is a result you can play. It's a test game running on WebAssembly with my custom runtime. And as you can see, there's a lot of information stuff on the console. So with the help with the tools, Sebastian also developed, like reading an ELF file to give debugging information for decode on web, helped a lot too. I think it's on Dub, called Wasm Source Maps. It's pretty nice stuff. And with that runtime, I was even able to port my engine to the PS Vita. Like I've looked a lot into the Vita SDK, and I found that I was able to use OpenGL2 for running its games. This thing was pretty more hazy than doing the WebAssembly stuff, because the free function behaved quite differently. There was use cases for use after free on the runtime I was using. In the case of the PS Vita, the free would also clear the memory it was storing. So there was a lot of non-stack traces there, so there was a lot of bug reduction to get things done. This platform was pretty complex stuff. So now I want to talk a little about the portability design. For making your code really more portable when you're working on it, a good thing you need to do is try to use reflection however you can. The first approach you can think about that for making it more portable is using interfaces, abstractions, or those kind of things. But the thing is that with reflection, you can make your interface a lot smaller. So because you don't need to have the exact same implementation for two things if you have this metadata. So this is a really cool feature D has that I think if you want to make it more portable, use how much you can that. The other thing is that D is very nice for metaprogramming. Like when you're needing to deal with Java, for example, you can just create some kind of UDA that binds to a Java module, and then you can just mix in your function to automatically convert your int type, float, objects, strings to the types recognized by Java, and making your code a lot cleaner. If you want to look in any kind of C, JNI binding stuff, you will notice that how ugly is that. It's almost unbearable how ugly C can get when dealing with that. This is pretty clear what it's doing there. You can see also in the right side, this is how Java access shared library functions. It's really straightforward. And yes, this is a really big interface. And this is interface for getting a new renderer running. Although it's pretty big, this same interface is able to wrap OpenGL from versions 2, 3, and 4, DirectX 11, and Metal. So I think you really should be using more interfaces in your code, because it really makes clear on what your requirements for making things running. Also, do try to keep those common things implemented in a single place, like wrapping your interface with some other kind of higher level accessible code. This brings the question, is OOP really slow? The thing is, OOP can be slow, but it's not necessarily slow. As you can see, it doesn't even increase 0.1% here in my testing with 10K dynamic sprites. All of that because you need to reduce the number of calls to your renderer. And this is the same thing I've been doing with the WebAssembly port. You need to always try to not use the bridge, not use the API, just use when you really need it. You won't suffer any loss from having like a renderer that is switchable in runtime. Like I could have done my renderer to be implemented at completion time, but then this becomes quite inflexible when you can just run through your configuration tool, and it just changes your entire rendering system. It's pretty easy to debug. It's pretty easy to connect to a GPU debugger too. So there's a thing about my build automation tool that it just does a lot of things. I have based it mostly on the libgdx project setup tool. There are really nice things about it. It's really portable, easy to configure. Anyone in the world can configure that for using what you want, but this is a big no-no. Needs Java runtime, Android SDK install, needs environment variables. That is basically what makes it hard to use. Environment variables, I think almost no one is even taught about that in college, but you still have to learn through it somehow, and this can be really game-changing to a beginner not using your thing or using. And the other inspiration tool was the Android SDK installation. It just really works. After you have this thing, you simply click there, apply, then it starts running. It's pretty nice, but it still requires Android Studio, which is just a big stone in your front. And I've used the Ars terminal for my style. I do wish to do a GUI in future, but this was just easier to get done. This build tool, basically you just select with arrows in your terminal, then you just click enter, and it will automatically build for the platform you're trying, automatically installing every kind of dependency you have. It doesn't require any kind of environment variable. I also used CI to distribute this as a separate binary, so you don't need even the language for running this tool, because it also automatically installs LGC for you and starts executing it. So this is a thing designed for any kind of user. Even I was impressed how convenient it is to have, because it's very simple to you just open the terminal and run dub. But when you're supporting all those platforms, things start to get quite hairy. You need to do custom scripts to run through your program. You need environment variables, which is pretty bad still. It can mess up your system. It's simply a lot better to just have a tool that does that all for you, including the programming language. As this is a project for a single person do it, like there was people opening issues, they were using other decompilers. As you've just looked into, I've done my own runtime, therefore using with WebAssembly. I can't really guarantee that it's going to work with my implementation. So sometimes we do have to limit ourselves if we want to get things done, because it's really unfeasible to support all those platforms with a lot of compiler versions. And this is a showcase looking on Windows. You would be surprised that running D for Windows, you at least need the Microsoft VC runtime. And if you want to build as shared libraries, you will also need Microsoft build tools. You can see it's pretty big there. It's 2 gigabytes, and that's because my engine actually optimized this download thing, because from the default Microsoft store you get 8 gigabytes. So it's just too big for me. And now looking into the feature for the engine, there's a lot of things I wish to do. I finally can develop games without worrying with a lot of refactors. It's just too much doing like 6 entire refactors. I have almost 70K lines of code already. And also, I believe this needs increased invisibility in the main thing I would change today in my engine is, instead of using the Win32 API, DX11, I would use the Ars window, because it already handles a lot. I believe that we should be using more D code instead of C code. It makes our life simpler, more portable. You won't need to be like Steven that had a lot of headaches. And you won't be doing any more kind of boring ports like replacing the arrow with dots. Yes, the other thing I want to work on is the iOS port. And for that, I will need to work in the external Objective-C qualifier. This is pretty important because LDC is required for the iOS, but working with the C++ metal bindings was simply just too ugly for me. There's a lot of less documentation. I want to make my project have how much documentation I can, because this is where beginners are looking for. Although mostly don't even read it, it's pretty nice to it at least be available, and also working on a higher level game framework. And for the medium long term, I think that developing a UI for the engine is pretty important, because when you're telling about this for non-programmers, like I bet mostly here use only Linux, I think like 5% of from you must use some kind of GUI for something, or even less. How much you guys use here UI, GUI? I bet you guys at least use Windows sometimes. Well, Linux is not really designed for, it's not really designed for users. It's just complex, but it's really unbearable how much you look at that, because when you're looking at the current Linux state, it's not more Ubuntu's fault, it's the programmer's fault, because they just got used to old Linux way. We just use terminal everything. That's a common term called BIY, build it yourself. Then it would not even run, because the guy there didn't say which compiler version he was using. He didn't say anything about the defines he was using. He didn't say anything. No documentation at all. He used hash define begin. It's just a mess. You can't read his code. And then after looking to users, because they are users, not programmers, I want to work on the PS4 and 5 porting. And from my experience dealing with Sony, it's not really impossible. I have some friends with actually got some support from Sony to develop their tools. It's a Haxe framework called Ka. And after that, he just said, well, sometimes you just need something to show, and they are looking it to you to be usable. So just looking to code is just not enough when you need to get into selling your stuff and things. You need to have also more visibility. I think showing D to other persons is pretty nice, but there's a big problem when you show D. There isn't many projects made with D. We don't even have an official GUI program right now. We have RSD Mini-GUI, and the other one I think Green is working right now. But it's just really simple. I think being focused too much in C, it's slowing a lot the productivity. Like I am almost sure that doing any kind of games right now with D, it will be just as fast as doing with JavaScript. And yes, 3D is stuff for another day. It's just too complex right now. there's two maths, and I'm not really that good in maths. And those are the acknowledgements I have. I don't think I would even be programming D if it wasn't for Adam today, because I don't know if I have ever seen, but I think he has more than 100 modules standalone for doing any kind of thing you really need. Like I have used this terminal thing, the audio decoding, font reading, there's just too much things. Audio formats from Pons. He helped me porting this thing to work for PS Vita and for WebAssembly. We are working to not using any kind of exceptions because this is what not my runtime supports. Exceptions just too complex for me to implement right now. The BindBC project, it really saved a lot of time when I was looking to OpenGL. And also, I think it's pretty nice for the D community because it created a standard where how you can create your bind, so it's pretty convenient. Thanks, Mike. There's the LDC compiler. This one is just the main thing here in this project. Hipreme Engine would not happen if there wasn't any LDC stuff because it's basically what compiles to every non-Windows Linux platform there. So it's pretty useful. Dub is a tool really nice that you have because every beginner can start with it. Like when you're trying to set up your first time trying to build C code, you just don't understand what you should be doing. There's makefile, cmake, xmake, luamake. I don't know how much build systems they have, and a makefile written in Windows doesn't work in Linux. And this is true for almost everything. Then you have cmake that you just don't understand anything they have wrote. Its language is just ugly. This is the image formats that Pons had done too. So your work has been pretty much appreciated. I'm not using any C library here. So besides of course the operating system and low-level APIs. And after that I bring 2 questions.
Could you show a game written in D, please?
Okay. I think. Whoa, my laptop is pretty slow there.
While you're doing that, we do have an online question from Ricky. Have you, after many significant failures, been able to understand what DLL import is, or is the current situation unacceptable for you as a user?
I can't understand those DLL things. It's just too complex. There's a lot of linker stuff there. I can understand that DLL export. Actually, I think I use DLL import in the C++ /win runtime there for the Xbox thing. So I understand the high-level parts. I'm not that nerd like Rick.
Yeah, I mean, you know, like it just DLL imports. It needs to statically link the dynamic link library to make that work on Windows. Does that sound funny? Yeah. Just generates a little static lib so that it handles the DLL loading for you. That's really all it does. But you know, this would be the WebAssembly stuff running, right?
Yes, you can see there in the console. There's a lot of metadata stuff that I put there because I would not be crazy to not let those comments go on.
I was just wondering, does WebGPU, is that part of your future at all? Does it interact with you, or are you working with like OpenGL or something that references that for you, or do you have direct access in the future, perhaps, to WebGPU?
You know, for the future, there's a lot of things to support right now. I used Directive 3D 11, so nowadays people only speaks about Direct 3D 12, and I asked some Microsoft employee, should I be using Direct 3D 12? He said, absolutely not. It's just too complex. You're working on a single person project with more than one renderer, so I like to keep things simple. If WebGPU is not that complex as Vulkan or Direct3D 12, maybe I will be looking into that, but I don't see myself looking into that because it's just too complex.
On which actual hardware did you manage to get this game to run?
This game is supported in every platform this engine supports. It's written once, you don't need to modify any line of code to make it work.
All right, and yeah, we're out of time, so...
Thank you.